Start the recording and then we will begin with the session. So, very warm welcome to all of you in our Glipmsing Guruvar series. Today, we are going to talk about letters BDD, and we would be taking a look at the tool for BDD, which is used with the C# programming language known as the SpecFlow, and the environment which we use for it is Visual Studio. So, let us have a look at the agenda. So our agenda is to first understand what is behavior driven development. We will then have a look at SpecFlow, which is effectively the BDD for .NET. We will be having a look at Gharken, which is the language of BDD, installation and setup of SpecFlow on our system, and how do we get started with SpecFlow with a very basic project. And this part we will be taking up in our next upcoming Glimpsing Guruvar series. So the idea is that I would want us to treat BDD as in a stand-in concept and not look at or do any integrations right now with Selenium, so that we first understand the importance of BDD as it is and de-link it with having any association with Selenium per se. So the first concept which we talk about is TDD, which is effectively test driven development. It is the software development process and it relies on a repetition of the very short development cycle. So, effectively, the first thing we do is we write a test using which we are going to drive the development, and then there is no code which exists. So, when no code exists, the test is obviously going to fail because whatever it is testing is right now not available. So, it is going to fail. Then we write something and we repeat the process and we tend to pass the test. Then we keep on refactoring, improving the code quality, ensuring we add more information to the code, and it is going to fail again, then green, then refactor, and that cycle continues. When we add it over another layer of domain over it and wrap it around behavior, it is then in a very basic and simpler terms, we try to go towards the process of BDD, but it is much more deeper than that. And what exactly is BDD all about? BDD effectively stands for Behavior Driven Development, and it is a process to explore, discover, drive, and also define the desired behavior of the software system. And how do we explore, discover, derive, and define the behavior? We do so by the help of conversation, which is crucial among all the stakeholders of the product. We do so by the help of concrete examples, which effectively become a part of our feature file and scenarios. And then there are examples given in it. And we are able to generate, with the help of the BDT tool, automated test, which ensures that the truth is available at any given snapshot to all the stakeholders as to how the progress of the product is being made. So it combines the journal techniques and principle of TDD with the idea derived from the domain driven design. So business becomes a very crucial part of the development process. And it is effectively a design activity where we build the pieces of functionality in an incremental form, and it is always guided by the expected behavior. It allows the developers to use the native language, that is our programming language in which the developers is going to code, with the language of the domain, which basically helps us in defining our code in a better format. And it also allows the developers and the stakeholders to focus why the code should be created in the first place, rather than the technical nitty-gritties of having maps or hashes, having classes or reflections. And it minimizes the translations which is going to happen between your business expertise and your technical experts, so that we all are effectively speaking the same language, and any misinformation or information loss or Chinese whispers, which we call it, do not happen because we all are trying to speak the same language with the help of the platform which BDD provides us. So, in general, in a behavior driven development process, we effectively have our client and business owner meeting and having a conversation as to what is required. Once that conversation has taken place, a word which we known as in specific to BDD called as the three amigo meetings happen between the analyst, the tester, and the developer. And the purpose or the output of this meeting is effectively a set of feature file. It is also a set of questions. It is a set of concrete examples. So the output of the three amigo meetings could be more questions if the scenarios are not clear, if the requirement are not pieced together. The output could be the concrete examples which basically take the shape of feature files and scenarios, and the output could go back into modifications. So this is what is generally expected from the three amigos meeting, with effective input is required from every expert on the team. The help of the feature files, we basically have the developer started writing down the code which is guided by the concrete examples, and with the help of the automated tests provided as input and binded to these feature files, we get a snapshot of our code and the product development, not the code but the product development in terms of behavior with every cycle. So if we look at the three amigos meeting, our input is our user stories and acceptance criteria is what is our output. The input is user stories. The output is in the form of learning of domain, questions, examples, and your acceptance criteria. The concept of BDD was started in the year 2007 in the QCon conference, where Dan North basically presented the concept of behavior driven development, and it was first written by him in the year 2003. The very first article on BDD is available here from the Dan North blogs, and it's a good article, rather a great article to read and go through to understand the idea where BDD was first introduced. Okay, so it talks about why and how BDD came into picture, why behavior is a much more useful and a powerful word than test, and how does it basically changes the perspective to approach any product development process. Now, from the perspective of BDD, we have to understand that the focus on behavior becomes our center point, because our end users generally do not care about the technical implementation of the project or of the product. For example, nowadays, let's take example of a mobile application. Okay, you go to the app store and or the play store and you try to get a application. Let's say you are trying to search for a social media application or a e-commerce application, and you download it. Let's not talk about the known ones, maybe some unknown ones, or maybe you're trying to look at an exercise, application for your health. What happens if the application immediately, uh, you know after installation, when you try it out, it starts hanging or it crashes? How much time do you think it takes us to uninstall it and move on to something else which has much more rating or much more positive reviews? We do so pretty quickly, right? We are not bothered as the end customers as to, oh, they must have developed it in Android or in iPhone, or whether it does it work with any other operating system. How about we try the web version? No, we don't even think about what language it was developed in or anything of that sort, which is technical per se in nature. What we are worried about is the behavior. Is it supposed to deliver what we wanted to deliver? And if it is not going to deliver, it makes no difference to us. So, as Michael Bolton has said, that the clients don't value the code as such, they value the things that code does for them, and that includes anyone and everyone under the sun, whoever is the end customer of the product, including the people creating it. Now, why focus on testing of the behavior is important? The user acceptance testing is all about behavior which a system basically acts upon in response to a user interaction. When we test at the functional and at the system level, we are effectively testing the behavior. And as testers, our focus should never be on the code. Our focus should be on the behavior, and as much as possible, we should be able to define the bug in terms of the behavior which is not working with respect to the product. And that's where BDD comes into picture and helps us shift our focus from requirements to the actual end product at hand. We always have the business or domain or the product requirement, why this product is being made. That perspective is always in front of us. And any requirement, any development aspect, any testing aspect is always spoken to about in the terms of behavior and the user acceptance. So, what BDD provides us with a shared platform, it merges the specification and the documentation, whether it is for development or for testing, into one cohesive whole. It is a living documentation. As our product is undergoing changes from this point of conception to the point of delivery, there are changes happening every single second. So, our living document or our BDD document ensures that everybody is always up to date and the automatic tests are developed by any BDD tool. The focus always remains on customers because what we describe is in the terms of end user perspective. We are describing it in terms of behavior of the product. So the end user customer perspective is always in mind. The business goal is always in mind for every stakeholder. And then there is less of rework available because teams can effectively protect them from a lot of regressions which keep on happening if we take approach of traditional approaches like waterfall and so on and so forth. For example, I am sure you must have built those matrices where you are trying to, test matrices where you are trying to map the test cases with the requirements or bugs with test cases and then eventually requirements. But gone are those days because with the help of BDD, we don't really have to do that because what it also makes available to us is a very powerful feature which is of automated test. So every line of the document written is actually binded with the actual code in the form of step definition, and we always get a snapshot of which scenario, which feature, which aspect is failing if any change happens. And that is why BDD becomes so very powerful. Also, another perspective of having these three amigo meeting at the conception of the requirements which help us generate these feature files, concrete example scenarios, is that if a bug or a deviation is caught at the requirement level itself with the help of all these three different perspectives in common place, a lot of effort and cost could be saved at the later production side of the software. And it has been found that the bug which is found at a which was available at the requirement level, and if it is found in production, it costs more than 90% of what it would have cost you to fix at the requirement level itself. So we get saved from all those um, mammoth mistakes. Now, generally, a BDD project structure has a business phase to it and a technology phase to it. So, we have our project, our features, scenarios, and steps at the business aspect of our project. And then we have our step definition, support code, any automation library, any tool, any of the libraries available at the technology phase of it. Now, if you talk about C sharp, the tool is SpecFlow. If you talk about Python, the tool is Behave. If you talk about Java, Ruby, we can use Cucumber, and for Java, we can also use JBehave. to basically apply BDD at the project development level. Is there any question so far? Anything you would like to talk about? Anything you would like to know or more? Or is there anything you would like to share? Please let me know. You can unmute yourself. If not, then you can please let me know the same on the Q&A part. Now, Gherkin is a language which effectively the tool Cucumber or BDD tools understand. It is the DSL for BDD, which is the domain specific language for DDD. It helps us in describing the behavior of the software without actually getting into the details of how that behavior is implemented. It solves two purposes: the purpose of documentation and the purpose of helping us with automated tests. Now, there is a proper structure to a Gherkin file which gets generated, and it is created with the help of some special keywords like feature, which is generally then followed by background scenario outline or scenario. Scenario or scenario outline is generally followed by three important keywords: given, when, then. The statements in given, when, then could be multiple in nature, which is basically created with the help of concatenation keywords like and, or if there is a negation but, or we can just use star. And then if our scenario is data driven or it requires some more examples to define it, to pass data to it, we use examples as a keyword here. So as stated, each Gherkin file begins with the feature keyword, and we have the name of the feature followed by description. This is generally followed by scenario, and if not scenario, if we are going to use examples to data drive it, we use scenario outline and background. Each scenario is a single concrete example of how the system should behave in a particular situation, which is effectively described by the given, when, then. Given, get the system into a particular state. When, you poke it or tickle it. Then you examine the known state. So our given is when we get the system into a known state. It is very important that the given is clearly defined. When you perform an action which your end user is supposed to do, then how the system should behave in that situation is what is written in then. As stated, scenario outline and backgrounds are used when we are basically going to use example to pass the data. Given basically helps us create our precondition, when is our actual steps, and then is the expected outcome of that situation. And then but our concatenation keywords if our multiple line exists in given and when. And you can provide a comment by using the hash statement. An example of a feature file looks like this. Feature that we have to process refund. A specific scenario that customer has their receipt. Given the customer has purchased a kettle for pound 10, so you can note in here that we are actually using a concrete example. We did not say that the customer has purchased some product for some amount. We actually mentioned an example of a product name and the actual amount the user has paid. And they have their receipts. When the sale assistant processes the refund, the stock inventory of kettle gets incremented by 1 and the customer card is credited with pound 10. The idea of writing down these concrete examples is to go on to details. Don't leave out anything for imagination or vagueness. That is the objective. Do not think about a tool or a particular library when you are trying to build these feature files. These are not your test cases. These are not your test scenarios. This is a feature file and a concrete example in the help of, or another word used is a scenario of how the behavior of the product should be in a given situation. Okay, these are not your test cases. This is not your documentation written to get supported by a particular library to drive the browser or anything of that sort. Please delink this information if you ever learned it through that way. Now, SpecFlow is the BDD tool for .NET which helps us bind the business requirements with the code. And with this, we will move on to talking about SpecFlow per se. The first is specify. The purpose of using SpecFlow is to specify the behavior of the system using human readable syntax, because that is what our concrete examples or scenarios or feature file are written in the form of. We define the specification in the problem domain using the language our stakeholders are comfortable with, and we create a living documentation of our system. We bind our tests to the specifications, and the tests are automated, which ensures that at any given snapshot, if our test scenario passes or fails, we get to know which behavior is passing or failing. It concerns on the forensic aspects of the development, and there exists a peace of mind which comes in knowing exactly what the software is doing and what it is supposed to do even after a significant amount of time has passed from its conception. Now, to set up the spec flow in the Visual Studio, there are two aspects to it. One is creating and setting up SpecFlow so that we can go ahead and create SpecFlow project, generate these concrete examples in the Visual Studio environment. The second aspect is the SpecFlow runner, where we actually try to bind the SpecFlow concrete examples automated test with the actual step definitions which are generated in the form of code, and with the help of a test framework we execute those tests. So the steps are, we have to open Visual Studio. In here we are using the latest Visual Studio 2019 Community Edition. You have to navigate to extension, go to manage extensions, and in there we search for SpecFlow. Once you find SpecFlow, you have to click on the download button. So this is my Visual Studio extension, manage extension, and in the marketplace I'm going to search for SpecFlow. And you have to go ahead and I already have it, so I don't see it, but whatever you don't have it, for example specs, I don't have it, you have to go and click on download here. Okay, if you have it, you get a right, you get a check mark icon. So go ahead and install SpecFlow for Visual Studio from the extensions manage extension into your environment. Once that aspect is done, and then you go ahead and create your SpecFlow project, because you would be allowed to create your SpecFlow project. How do we do that? Let's see. So once that aspect is done, when you launch your Visual Studio and you create a new test project, here you would start getting an option of a SpecFlow project. You select it and you click on next. Here it would ask you to name your SpecFlow project, and I would say create. Then I would have to select the .NET Framework 4.8 and any of the test frameworks which we are comfortable with, so that our tests can get executed, the automated test which gets generated from the binded code. And I click on create. If you look at the Solution Explorer and the structure of your project, this is a by default feature file which generates up. In the hooks, you can write any code specific to the hooks. The step definition is the technical part of your code where the actual coding takes place by binding the feature file with the actual code. So this is our feature file, and this is our step definition for this feature file. Each of the statement in the feature indeed is implemented here in the step definition, but inside the code we see scenario context pending. Let's say I build the solution. Now I open my test explorer. I would get this test as in my tag. From where I am getting my tag? Because in the feature file, this tag is declared called as my tag. So any set of features or scenarios which use my tag will get available inside it. And if I click on the play icon, it says one succeeded. If I open the test part, it provides us with more detail. Total 1, succeeded 0, ignored 0, pending 1. Okay, why we get pending? Because right now nothing works. There is nothing available, and we ourselves has written that it should throw scenario context dot pending. It should throw that information. If you go to test explorer, here this triangle shows under construction or skipped. You click here by saying open additional output for this result, and you say given the first number 50 pending, second number 70 skipped because of previous error, skipped because of previous error, and this is pending still. Okay, is this clear of how we installed SpecFlow? And then we created a demo project of SpecFlow nature. By default, it came with an example of a small calculator feature file with the step definition in which nothing was implemented, and we was able to build the solution and run the test. Is this clear to you all what we have done here?
Hello, hello, hello.
So if I click on any of the scenarios, like the first number or second number, I would get the detailed information of given the first number, second number, when the two numbers are added, and so on and so forth. Okay. So this is a very happy scenario which happened. Now let's try to fail it. A simple way to fail is that I am going to change the expected output to, let's say, 100. So when the first number is 100, second is 70, when I subtract it, I get 100 again. Let's see what happens. So we got subtract two numbers, which is basically failed. Let's see the output. This time what happens? So if you see the output, we get the error expected 100 but was 30. Okay. So we got a failure in here, and it shows very nicely in our execution report, and quickly we are able to identify that one of our expected behavior has failed. Not the test, not a tool or a library was into picture, but one of our expected behavior of the product, which should be about when two numbers are subtracted, is failed. Now let us try to take help of example. So what I'm going to do is I'm just going to take this one to basically show the help of example. Instead of writing down actual 50, 70 or 120, we basically take help of something called as placeholders. So what we are taking is we are taking help of something called as placeholders. And then we use the word background, and let's say reset the calculator to 0. Okay, right now we are not generating any action. Okay, ideally background is also supposed to or could also have given and when then, but right now I am not generating any action to it. Let's try to build the solution first. So it talks about two being succeeded. Why it talks about two being succeeded? Because every example for this concrete scenario is taken as one particular scenario in itself, which basically gets executed with its example data set. Okay. So if you go down, you get scenario add two numbers and this one. Okay. So these are two scenarios which are using your two different data points 10, 20, 30 and 30, 40, 70. This you do with the help of examples. Now let's try to add another scenario which was subtracting numbers. Given the first number is 100, 30, 70, and here I say subtract. Or let me just change the word to subtracted. As you can see, it was not able to get it because I used another keyword called as subtract instead of subtracted. So this is already implemented. Now let us try to add a tag to it called as secondary function, and the first one we will add core function. Your tag could also be at the feature level. That's absolutely allowed. In that situation, all your scenarios within that feature become part of one tag. So you get core function and secondary function. Let's try to run only secondary function. This has passed. This is our logs. This is how it gets generated, to which we are looking at the HTML. Okay. Now, there is an interesting variable available to us called as scenario context, which provides access to a variety of functions and information which could be find out about a scenario. It could be used to pass data between the scenarios. It could be used to store data from the execution of the scenarios, and many such other situations could be made simplified with the help of this scenario context variables, which helps us in binding the scenarios together. So if we look at here in the step definition level, let us say I want to print the information of scenario title before I go ahead and start a scenario execution. For that, we are also going to make use of something called as hooks. What exactly a hook would do? They are used to perform any automation logic, logs, or information at a specific time or an event. Example, before a scenario, after a scenario. And how are we going to implement it? We are going to basically make use of the before scenario attribute. And in here, I am saying that I want to write the title associated with the scenario. And in the after scenario, I want the description to be printed. So let us try to give this information. So title is already there. Let's give this information. Okay, now let's try to build the solution and then try to run it. So what we have available is the usage of scenario context scenario info title. So if you just look at this variable, scenario info, arguments, description, tags, title, all this information, whatever the scenario has is available. Let's try to get the tag part as well. It is possible that your one scenario is associated with more than one tag. So only in before it is fine, not required in after. Now let's try to build it. Let's try to run all the tests. Go to our test output. This is our HTML file. Okay, so let us see. So feature is calculator. There are three outputs. Let's try to see. Starting add to numbers system.string. So tags could have more than one information. Let's look at our output. So this is basically the before scenario working. This is basically the after scenario working. This is the description which got generated in the after scenario because we gave it in the feature file. So logging and all that becomes very much easily doable instead of associating multiple libraries or writing much more code. We get all this with the help of the tool which we are using. So therein lies the power of using BDD and tool like SpecFlow in your C# to create your project. So with that, we have come to the end of discussion for this particular concept today in our Glimpsing Guruvar series. If you have any questions, please ask. I will try in best possible manner to answer it. If not, then we would be ending the session. Thank you so much for your availability today in this learning series. If you have any questions, you can go ahead and ask me. Okay. Yes, the recording would be available. So if you go ahead and just even write down, let's say we write down further scenarios. Let's say we now write down the scenario for multiplication. Yeah, I'm trying to answer your question. So let's say we multiply 10 by 10, we get 100. And in here, instead of subtracted, we have to use another word, multiplied. And let's say we want to generate the step definition, copy method. You go to here, calculator definition, and try to place your code in the right section. By default, you will get it as pending. Okay, so even if your actual code exists in here, but in step definition you are not calling the method and you have written it as pending, your output would come out as pending. This scenario in execution would show you as pending because you have not yet binded your code. Okay, You have not binded your code with your step definition. That part is not taken care of. You get no traits because there is no tag associated. So multiplication of two numbers in the calculator aspect, there are no tags associated. So if you run it, this particular aspect is basically pending. So it would be skipped. If you see the output, we will get one of the scenarios as skipped. Okay, or pending. See, the rest part would get skipped. To avoid it, you go ahead and you say you bind the code and you call in here the multiply function. Now let us try to give it a tag as well. Let's say it becomes a part of our core function. Let's try to build the code solution. Let's go to the test explorer. So in core function, we have now multiplication added. Okay, right. So this is how it would be working. Okay. So depending upon which output you are looking at, we will see this. If you want to see the complete output, you can go ahead and go to the test part and open the HTML which gets generated for this particular section of your execution. Okay. Okay then. Thank you so much. Have a great week ahead. Bye. Thank you so much for attending. Bye everyone.